next topic is going to be geometric sequences. So first let's review arithmetic. So for arithmetic, it means we're adding and subtracting the same number every time in our sequence. Our recursive formula for arithmetic is where we say a sub n equals, and then we say our first term, which will be a sub n minus 1, or the previous term, plus whatever that common difference d is. So we're adding whatever the common difference is every single time. So our next term will be the previous term plus whatever the common difference is. Our explicit formula is where we have a sub 1 plus, and then in parentheses, n minus 1 times d. And we can plug everything in and simplify this one down to look like a linear equation, a linear model. Geometric sequences, instead of having a common difference d, we have a ratio r, and you are always multiplying by your r. So if my common ratio was 3, where I multiply by 3 every time, my r would just be 3. If I'm dividing by 3 every time, I still have to think of what I'm multiplying by. So dividing by 3 is the same as multiplying by 1/3. So you still have to consider it as multiplying by something every time, even though maybe we're getting smaller. Alright, so our r is whatever our ratio is. Our recursive formula, we're going to say a sub n equals, and we're going to take our previous term, so a sub n minus 1, times whatever that ratio is. Okay, that's our recursive formula, the previous term times r. Our explicit formula is the one that we kind of write to where it's more generic. So we would say a sub n equals, and we have our first term, times r, whatever that ratio is, to the n minus 1. Okay, now if you remember, whenever we have a variable in the exponent, we call that an exponential equation. If you think back to exponentials and we went to those word problems with interest, we would say a equals p times 1 plus r to the t, for example. And we said that p was our principal, or our starting amount, and then whatever's in parentheses is the rate that we're growing or decaying, depending on what type of problem it was. Well, up here is the same way, that a sub 1 is the initial amount, that's our starting value, and then that r is the rate at which we are changing, whether it's increasing or decreasing. So this put together would make an exponential curve on our graph. So if I would look at these 4 examples, I want to determine if they're arithmetic, geometric, or neither, and then find the common difference or ratio when necessary. So for the first one, to go from 1 to negative 5, I subtract 6. Negative 5 to negative 11, subtract 6. Negative 11 to negative 17, subtract 6. So this one's arithmetic, and my common difference is a negative 6. Alright, to go from 3 to 3/2, which 3/2 is 1.5. Alright, I can either subtract 1.5 or divide it by 2. Alright, so for this one, you kind of think both ways. 1.5 to 1, I'm subtracting a half. Right, so I went from minus 1.5 to minus 0.5, and then 1 to 3/4 is minus 0.25. And there's no way to really have a simple division or multiplying by something to go through these, so this one we would say is neither. Alright, then to go from 108 to 36, okay, I could divide by 3. Alright, 36 to 12, divide by 3, and 12 to 4, divide by 3. So because I'm doing the same thing every time, it's going to be geometric. But remember, your ratio can't be dividing. It's got to be whatever you multiply by. So my r would be multiplying by 1/3. And then for the last one, to go from negative 2 to positive 4, alright, I have to add 6. And then 4 to negative 6, subtract 10. And negative 6 to 18, add 14. Alright, or I could try to look at it multiplying. To go from negative 2 to 4, I have to multiply by negative 2. But then to go from 4 to negative 6, it's not multiplying by negative 2. So this one we would say is neither. So you're just looking for your pattern, either adding the same thing every time or multiplying the same thing every time. Alright, so now I want to find the next 3 terms and write the recursive and explicit formula. So for these geometric sequences, okay, this is a number 1. So I go from 64 to 16 to 4. So each time I'm dividing by 4, which means that my r would be a 1/4, because that's what I'm multiplying by. So my recursive formula would be a sub n equals a sub n minus 1 times 1/4. right? And then my a sub 1, we add in there that's 64, just so we know where to start. All right, and then my explicit equation would be a sub n equals, my first term is 64, right? My r, my ratio is 1/4, and then to the n minus 1. And then my next three terms would be 1, 1/4, and then 1/16. All right, for number 2, I go 2 to negative 12, I multiply by negative 6. Negative 12 to 72, I multiply by negative 6. So my r equals negative 6. So my recursive formula, a sub n equals a sub n minus 1 times negative 6. And we'll put that in parentheses. All right, and then a sub 1 is 2. For my explicit, I would have a sub n equals, my initial term is 2, and then in parentheses a negative 6 to the n minus 1. And then my next three terms gets to be kind of big numbers, and keep in mind my numbers are going to alternate positive and negative because I'm multiplying by a negative. Alright, but a positive 72 times a negative 6 would be a negative 432. And then negative 432 times negative 6 is going to be a positive 2,592. And then one more time would be a negative 15,552. We got big real quick, which goes back to the exponential curve.